Hi everyone, this is your Sakyam Yaganteshwardu. Welcome back to our machine learning session. In today's session, I'm going to explain in depth about what is K nearest neighbor, how to do calculate nearest neighbors for the given new point, and all those calculations and in-depth details about K nearest neighbors we are going to explain for the classification problem. These K nearest neighbors can be applied for both classification and regression, but target for today is we are going to discuss about classification problem. This KNN is based on instance-based learning. So what is instance-based learning means? For example, you are going to work with diabetes prediction or COVID-19 prediction. Then let us say you are having 1,000 diabetic patient records. What this KNN will do means all the available cases, nothing but all the available records it will take, and it will calculate the distance for the new point. How to calculate the distance? We'll see with an example. After calculating the distance, and if I mention three nearest neighbors, it will choose the three nearest points. Based on that, it will classify the new data set. So that we'll see with an example how to do that nearest neighbors and how to choose the final class. And here, one more important point is it is not going to do any assumptions. It will consider all the available records in the data set, and then it will does not make any assumptions about the distribution of the data, making it as a non-parametric algorithm. Means it will not choose any particular record, or it will not choose any particular assumption to make the final decision. It will consider all those records to find the final classification of the new data point, and it is majorly based on the distance metric. Majorly, we are going to use Euclidean distance. What is Euclidean distance? How to calculate the Euclidean distance for the given data point, and already existing diabetic patients or COVID-19 patients records, how to calculate that Euclidean distance. We are going to see with an example. Let us see. These are my diabetic patients, different classes. And if a new point comes, then how to calculate, how to find the nearest neighbors, and based on that, how to classify the given data set, we'll see with an example. Let us see. And all of us know what is supervised learning, right? Because now I'm going to show you classification. Example, classification is a supervised learning. And this KNN will be applicable for both. We can able to apply this for both classification and regression. And in today's session, I'm going to explain for classification. And if anyone missed my sessions on supervised learning or classification or regression definition, just go and watch. You can get a clear clarity. What are these type of data sets? And classification data set means my input having both, my data set is having both input and output. And if the output consists of 1 or 0 type or yes or no type, or very limited values in the output variable, then we can say it is a classification problem. Let us see what are the steps for KNN. So steps for KNN. First, choose the number of neighbors. Choose the number of neighbors. Choose the number of neighbors. So for example, I wanted to find 3 nearest neighbors for my given data set. So then K becomes 3. If I want 3 nearest neighbors, then K becomes 3. Like this, how to choose which value is better means don't choose very high number of K value or very low number of K value. So this K, what is exactly K means? If you see here, for this new data point, if I have to classify whether it is class A or class B or class C, First, identify which are the nearest neighboring points for this point in order to classify whether it is very nearest to class A or class B or class C. So then I need to find some nearest neighbor so that I can do the final classification. If I choose 3 as a K, then it will find 3 nearest neighbors for that point to find the final classification. And more about k value, maybe I will take a separate session how to choose k value, which is the exact means which will yields better classification. That we can take a separate session. But here you can remember what is k means, which are the nearest points for the new data point. And second step in k nearest neighbors is calculate the distance. Calculate the distance. Here, as I told, majorly we are going to use Euclidean distance, and there will be some other metrics like Manhattan distance and so on. There will be some other distances. But here for this problem calculation, I'm going to use Euclidean distance. How to calculate Euclidean distance is square root of. So let us say my data points are x1, y1, z1, and so on. This is first point. And second point is x2, y2, z2. Let us assume these are the points. Then how to calculate the Euclidean distance means x2 minus x1 whole square, x2 minus x1 whole square plus y2 minus y1 whole square, y1 whole square plus and so on. If you have n number of features you need to do, so plus z2 minus z1 whole square plus and so on. If you have n number of features, you can do calculation like this. Square root of x2 minus x1 whole square plus y2 minus y1 whole square and so on. So first step is you need to choose k value. So which one you wanted to choose based on your requirement, you can choose the k value. And second one is you need to calculate the distance. And third step is select the neighbors. Select the neighbors. Means you are having, let us say you are having 1,000 diabetic patients data. Diabetic patients data. And my requirement is to choose three neighbors. Then I need to calculate the distance between these 1,000 points. Let us say 1,000 data points, and the new point is some new patient record came. For this new patient record, I need to calculate the distance between all these 1,000 points. And finally, I need to select whichever the nearest neighbor points for this new point. We'll see with an example. And finally, vote for the neighbors. What is this meaning? We'll see with an example. Vote for neighbors. And finally assign the class. We'll see with an example. So first step is choose k value, calculate the distance, select the neighbors, vote for the neighbors, assign the final class. Let us see simple example. Let us say I have two classes, class A, class B. Class A, let us assume that is diabetic patient. Class B is non-diabetic patient. Class B. For simply understanding, I'm going to explain with some simple, very simple data points. But later you can apply for the data set, whatever you are going to work with a diabetic patient or heart disease or COVID-19 disease, whatever you want, you can calculate the distance like this. So whatever the process I'm going to explain, right, with simple data points I'm going to explain, but you can able to apply the same thing for any data set, whatever you are going to work. Let us say I'm having two classes, class A and class B. Let us assume there are 3 points in class A. So class A, first point is 1, comma 2, and second point is 2, comma 3, and third point is 3, comma 3, 3, comma 3. So this is my class A points, and class B points are something like this: 6, comma 5, 7, comma 7, and 8, comma 6. So let us assume 3 points in class A and 3 points in class B. And my requirement is if I get a new data point. So let us see, new point is something like this, 3, comma 4. So for this new point, I need to classify whether it is class A or class B. Class A, class B. So I need to find whether it belongs to class A or class B. How to do this classification is, first let us assume as per our step, I wanted to calculate 3 nearest neighbors. Let us assume first step, I am choosing k equal to 3. So I wanted to find 3 nearest neighbors. For that, what I need to calculate? Distance between these points. Distance between these points. So first point is 1, comma 2. So in class A, 1, comma 2. And my new data point is 3, comma 4. So 3, comma 4. I need to apply Euclidean distance formula. So what is Euclidean distance formula? X2 minus x1 whole square plus y2 minus y1 whole square and so on. So square root of x2 minus x1, that is 3 minus 1, 3 minus 1 whole square. So this square root is for all the points. So that is x2 minus x1 whole square plus y2 minus y1, that is 4 minus 2 whole square. 4 minus 2 whole square. And if you calculate this, so that is square root of x2 minus x1, that is 3 minus 1, that is 2 square is 4 plus, and 4 minus 2 whole square, that is 2 square is 4. Square root of 8. Just calculate square root of 8. So square root of 8. So approximately square root of 8 value is around 2.83. Just use some calculator. Then you can get what is square root of 8. It is around 2.83. So usually square root of 9 is 3, right? So square root of 8 is approximately around 3, that is 2.83. This is my first point. Similarly, I need to calculate the distance but between the remaining other points. So let us say my second point is 2, comma 3, right? So let us take 2, comma 3. And this is the new point. Your new point will not change. My aim is to calculate the distance between all those points, and whatever the 3 nearest neighbors I need to choose, right? I will tell you how to choose the 3 nearest neighbors. Now, here 3 minus 2 whole square plus 4 minus 3 whole square. So 3 minus 2 whole square plus 4 minus 3 whole square. This is my first point. First data point distance, and second point distance 4 minus 3 whole square, that is 3 minus 2 is 1 whole square is 1, and 4 minus 3 is 1 whole square is 1. So square root of 2. square root of 2. So approximately it is around 1.41. Approximately around 1.41. Like this, remaining all the data points I need to calculate. So next third point. Third point. So what is my third point in here? 3 comma 3. Third point is 3 comma 3. And my new point is 3 comma 4. So see here 3 minus 3 whole square plus 4 minus 3 whole square. That is square root of 0 plus 1. Square root of 1 is 1. So this is the distance between third point. Like this, calculate whatever. So for example, in your data set, you are having 1,000 data points, means you need to calculate the distance between all those 1,000 points and between new point. Then you can able to find the nearest neighbor for your new data point. So our fourth point, let us see what is our fourth point. So our fourth point in data set is 6 comma 5. So 6 comma 5 is our new data point. So 3 minus 6 whole square plus 4 minus 5 whole square. So 3 minus 6 means minus 3. Minus 3 whole square is minus 3 whole square is 9 plus 4 minus 5 whole square is, that is 1 square, that is 1 square root of 10 square root of 10. So approximately this value is 3.16. 3.16. And similarly 5 and 6, for simple calculation I have taken 5 6 points, but usually we'll get thousands of records. For all those records it will calculate, our KNN algorithm will calculate the nearest distance between all those points and will take the best nearest points. So what is our fifth point in our data set is 7 comma 7. So one new, existing data point is this, and new data point is 3 comma 4. That is 3 minus 7 whole square and 4 minus 7 whole square. So 3 minus 7 whole square is minus 4 square, that is 16. And 4 minus 3 is minus 3 whole square is 9. So 25, square root of 25. Square root of 25 is 5. Square root of 25 is 5. And finally, our last point, sixth point. Our last point is sixth point. What is our sixth point is 8 comma 6, right? 8 comma 6. 8 comma 6. See here, 3 minus 8 whole square and 4 minus 6 whole square. That is 3 minus 8 is minus 5, that is 25. And 4 minus 6 is minus 2 whole square is 4. And that is square root of 29. And if you are able to find square root of 29, it is around 5.29 something. 5.39 or 5.29 means, which is more than 25, right? More than 25 and less than 36, it is around between 5 and 6, that is 5.39. And now if you list down your points and corresponding distance, so see here, already we calculated all those distances. And this is our first point. And next, first, second, third, fourth, and fifth, and sixth points, right? So just I'm putting all at one place and our calculations so that we can find which are the nearest data points for our new data set. And this is class A data points, and these are class B data points. And our new data point is, what is our new data point? 3 comma 4, right? New data point is 3 comma 4. And after calculating the distance, so 1 with the new data point distance is 2.83, 2.83, and this is 1.41, and this is 1, distance is 1, I think 1 only, right? 1. Next 3.16, 5, and 5.39. This is around 3.16, 3.16, and this is 5. Distance is 5, and this is 5.39. So now we have calculated the distance between the new points, new data point, and existing data points. Our next step is choose the nearest neighbors. Choose the nearest neighbors. Nearest neighbors means which are having less distance. Which are less distance means now I need to choose 3 points because initially we assume, right, k equal to 3. So if I have to choose 3 nearest data points, see here which are the less distance. So this point is very less distance. This will be very nearest closest point to the new data set. And next nearest point is 2 comma 3. And next nearest point is 2.83. In case means here I'm getting class A values nearest, but sometimes we'll get class B also close nearest. Then you need to choose the vote. See here, these are the 3 nearest points. In this scenario, for my new data point, there are no issues because directly I'm getting the point which are the very nearest, all are the class A data sets only. So these are the 3 nearest points for my new data set 3 comma 4. Now vote for the classifier. So our next step is, what is our next step? We need to calculate the distance and select the neighbors and vote for the neighbors. So how to vote means this is a class A data point. This is also class A. Class A means how many total votes for class A? So class A. So there are 3 votes because there are 3 nearest points for the given data set, and for class B, there are no data points which are nearest to my new data set. Means as per the distance metric after calculating the distance. So here 0 votes. And finally, classify, assign the final classifier. So last step is assign the classifier. Assign the classifier. Assign the classifier. Here class A having 3 votes and class B having 0 votes. Nothing but finally I can assign the new point 3 comma 4 as the class A. Class A. Class A. So let us assume, let us take one more point. Let us take one more point. Let us assume 1 comma 1 will be the some fourth point in class B. Let us assume 1 comma 1 will be the fourth point in our class B. If I calculate the distance in similar fashion, so let us calculate the distance for our 7 point. 7 point. So that is 1 comma 1 and 3 comma 4. 3 minus 1 and 4 minus 1. That is 3 minus 1 is 2. 2 square is 4. And 4 minus 1. Let us assume instead of 1, 1, I can take one more point, 1 comma 2 in 7th point. See here 4 minus 2. So here also I'm taking one more point, that is 1 comma 2 only. So if I calculate the distance between this, 3 minus 1 is 2 square is 4 and 4 minus 2 is 4, nothing but 8. 8 is nothing but 2 point something, 2.83. 2.83. So if you vote here, again one more point which is closer to this, class B also having. Now if I take the nearest point, so class B also will get one vote, because it is also nearest point, even though it is having, because class A having 3 votes and class B is having 1 vote. So which one I can choose? Class A only I can choose, because there are 3 votes, 3 nearest points for class A and only one nearest point for class B. Which one I can choose? I can choose class A, because there are 3 votes for class A. Like this you can calculate the distance. Let us assume you are getting some diabetic data set. Let us take some diabetic data set. So how you can apply the same thing for your diabetes data set is, so let us take some diabetic data set. You can find these data sets in Kaggle or any machine learning repositories you can find. So these are my inputs. So let us assume your first record. So let us assume you are having 1000 records and this is my first record, record 1. And first point is pregnancies and next is what pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and this is outcome. So this is outcome, means diabetic patients. First what you need to do is you need to separate all the diabetic patients and non-diabetic patients separately. So how many, let us assume these are the points, right? Totally 268 records out of 768 records. So first separate all these points in class A and separate class 0. So nothing but non-diabetic patients. So separate class A patient records and class B patient records. And if you get a new record, let us assume your new record is something number of pregnancies are 5 and glucose is something 135 and blood pressure is something 71 and skin thickness is something, let us assume 0 or something zero point 0.5 or zero point 0.1 and insulin is 32.6 and BMI is something 0.527 and diabetes pedigree function. So I think we are missing one thing. Glucose is this, and number of pregnancies, glucose, and then blood pressure. And here we missed skin thickness, right? Skin thickness is something I can say 34, and insulin is something zero point 0.1, and BMI and diabetes pedigree function age is something 45. So then this is my new point. You need to apply the same Euclidean distance formula, that is square root of, so 5 minus 6 whole square, 5 minus 6 whole square, 5 minus 6 whole square plus square root of 135, 135 minus 148 whole square. Maybe you can try for a one record so that you can get a better understanding of how you can decide a class for your one point. So that's why here I'm having 1000 records, right? If I have to calculate the distance between all those 768 records, it will take around some 4 or 5 hours if I have to do some manual calculations between the new data point. If I apply my machine learning algorithm, it will calculate in few seconds, it will find the nearest neighbors. But here, if you want to do manual calculation, minimum you can take a lot of hours to do manual calculation. That's why I didn't take in this long data set to show you how to calculate the distance, but you can follow the same steps. How to calculate the distance between your data points is you can do the same steps to calculate the distance and find the final votes, and then you can find the final class. In our new data point, so class A having 3 votes and class B having 0 votes. That's why we are taking it as a class A. And similar calculations, that is 135 minus 148 and 72 minus 71 minus 72 whole square, 72 whole square, and so on. So here I'm having some 7 to 8 features, right? For all those features, you need to calculate this, you need to apply this Euclidean distance formula, that is 34 minus 35 whole square, and so on. You can apply the same formula. 34 minus 35.1 minus 0 whole square plus 32.6 minus 33.6 whole square plus 0.527 minus 0.627 whole square plus 45 minus 50 whole square. And don't do any minus for this. This is our class, right? Finally, we are going to decide whether it is class 1 or class 0. So for this output, no need to do any subtractions, because our data point, we don't know whether it is a diabetic or non-diabetic. That is our task. We need to find out whether it is diabetic patients or not. So this is just one point. Like this, you need to apply the same formula for all those 768 records. And so find, let us assume if you take 5 neighbors, and out of 5 neighbors, let us say 3 neighbors are, so 3 neighbors are diabetic patients, diabetic, and 2 neighbors are non-diabetic, and then, so that is 0, and this is 1. Then how you can decide your final record? So this input record, how you are going to define this input record is, you can classify that as a diabetic because most of the votes were diabetic record. Like this, I hope you understand, right? What is the important thing here is you need to consider all those data points in your data set and take your new data point, calculate the distance between all those points, and find the nearest neighbors and vote for your classifier. And finally, whichever the class having the major votes, you need to consider that as the final class for your input record. So very simple concept. So all these steps you need to apply. First, choose the number of neighbors, calculate the distance, and select the final neighbors and vote for the neighbors, assign the final class. Like this, we are going to apply our KNN for the given data set. In the next session, we'll see how to apply scalar. Here I showed you manual calculation for the distance between the new point and existing points, right? And there I will show you how to apply this KNN by using Python package called as scikit-learn. Directly, no need to do all these manual calculations. But if you apply our machine learning algorithm, it will take care of all these calculations. It will find the neighbors and then it will find the final classifier. And that's why we are preferring Python. Means if you go to packages, all the code already predefined. If I want to do this manual calculation, it will take a lot of hours to do all those calculations. But if I apply my machine learning algorithm, which is there in scikit-learn, which will calculate in few seconds and which will find the final classifier for your input record. So I hope you understand the behind mathematics of our KNN algorithm. In the next session, I will show you how to apply KNN machine learning algorithm on top of diabetes with Python program. Thank you all.